Right now, your computer is managing a constant influx of data. You might be streaming a high-definition video, downloading a large file, and receiving messages, all at the exact same time. Every single piece of that incoming data is addressed to one specific destination, your device's IP address. An IP address is a numeric identifier that pinpoints your computer's location on the network. But this creates a logistics problem. If all these different data packets are flooding into the exact same IP address simultaneously, how does the machine keep them straight? Why doesn't a video stream accidentally load inside your email application? The IP address only gets the data to your hardware. To route that traffic to the correct software, your machine relies on a secondary sorting mechanism hidden inside the system. You can observe this sorting system in real time using a built-in utility called Netstat. Netstat is a command line tool used to display active network connections and port activity on your computer. When you open a command prompt and type netstat-n, you generate a map of every active connection your machine is currently maintaining. Attached to the end of every IP address in this list is a colon followed by a specific number. This numerical value is a network port. This terminal output shows how your device organizes the chaos of the internet, using these logical connections to keep your data streams separated. Isolating one line from the terminal reveals a connection's two-part structure. The IP address is the first coordinate, locating the physical hardware on the network. The port number is the second coordinate, the specific doorway to the exact software service requested, like a web server. This dual coordinate system is mandatory for routing. Without the port number, the data would reach the correct building, but have no way of knowing which room to enter. The foreign address in our diagnostic output represents the external server your computer is communicating with. External servers use well-known ports, occupying a permanent range from 0 to 1023. Most web servers use port 80 for standard traffic and 443 for secured connections. Other services, like FTP file transfers, require a different standardized doorway, like port 21. These rigid, standardized numbers ensure that any computer in the world knows exactly which port to request for a specific service. If we look back at the local address, your own machine, the port numbers are different. They are often highly irregular, 5-digit numbers. Dynamic or private ports occupy the range from 49,152 to 65,535. These are temporary channels generated by your computer for a single session. When requesting a web page, your browser assigns itself a temporary number to act as the return address for incoming data. This temporary assignment is what prevents a returned web page from being mixed up with incoming email or a file transfer. Millions of these precise logical handshakes happen simultaneously across the vast global network without any interference or delay. The process relies on this consistent loop, a temporary dynamic port connecting to a permanent well-known port, anchored by two unique IP addresses. This numerical separation is what allows your device to maintain order, ensuring every packet finds its correct destination even when you run dozens of applications at once. Tools like Netstat allow us to see this architecture in action. By looking past the graphical interface, you can see the mechanical logic that dictates how your computer interacts with the web. Understanding network ports provides a direct view into the hidden infrastructure that makes the modern digital world possible.